and welcome in today's video. Today we are going to model the previous question which we solved by hand calculation using a force method, and we are going to check the result which we got from hand calculation with the software. And of course this video or this tutorial is going to serve also as some good example on how you can do some basic modeling on Autodesk robot software. So basically this is the frame which we're going to model, where we're going to have that the lengths of the members are going to be equal to each other 5 meters, and then we're going to have that the distributed load on top is going to be 1 kilonewton meters, and then we have this 2-pin support, and we need to keep in mind that how we solved this frame by choosing those case 0 and case 1, which of course we are going to model it just to have an understanding how to do it here on Autodesk Robot software. So without any further ado, let's create a new model, and yet we are on a 2D frame. And the first thing to be done is to define the shape of our frame, and as mentioned we had the length 5 by 5, and we just go to members, and the cross section doesn't matter that much, as while we do our calculation we are going to ignore the self weight of the structure. So now let's continue to model the structure, where we start at point 0, and then we go upwards at 5 meters. Next we select the end node, and we go at 5 meters again, as our frame was 5 by 5. And the next step to be done is to define the support conditions, where we had a pin here and also a pin here. So we just go to assign a support, and our support is going to be pinned, and this is the configuration for a pin support. And now we just select the nodes one by one, and we can see that now we have added the supports on the frame. So now our structure is stable, and the next thing to be done before adding the distributed load is to define a load case. We just go here to cases, and we just press add one, add load. And now we can go to the load definition and add a 1 kilonewton per meter load on the member, and we need to assign a member load. We go to the uniform load, and on Z direction, as the positive direction is indicating upwards, we just press -1. And now we select the members where we want to assign this distributed load, which is going to be member number 2 here. So now we show the value and the distributed load as well. So we can see that now we successfully added the load into the structure. So now we can run the analysis. We have results which are available, and now we go to loads, so we can remove the dead load or the self weight of the structure. And now we just do it in this way for simplicity, and then we go back to start and we recalculate. So now we have the structure, and if one wants to compare the results, so from the previous video we got that the inflection point is going to be located 0.62 meters from this node going right. So now if for example wants to see the diagrams, let's go quickly. I prefer to use these settings. And if one wants to show the bending moment, or for example if one wants to show the reactions, they can pull this on, and remember to tick on the description, and then we can just apply, and we're going to have the values. So in order for us to see where the inflection point is located, we can just hover the mouse on the second member and select it. We right click, and then we go to tables, and we choose forces. Let's say table filtered to the current selection. So one thing that I would like to mention, as I mentioned on the previous video, we're not expecting any inflection point here, as the bending moment will be linear without changing from positive to negative value, and this can be seen here. So now we click OK, and we are going to have the results for member number 2 here. Now if you right click on this gray area, we go to table columns, and now we go to the division points, and we just select this option which has characteristic points as we did before. Now we just hit refresh, and we can see from here that the point where the bending moment switches sign from positive to negative over vice versa is going to be uh, at x equal to 0.62 meters, which comes to say that the result which we obtain parametrically by hand calculation is correct and is safe to be used in the future if some of these components are changing, meaning H and L. So this was about checking this one, but also if one wants to build case 0 and case 1, they can easily do it by just selecting this frame, for example, and let's go to tools. We just need to add this edit bar here. Alright, we close this one. And yes, so now we just want to copy this twice. We have the copy command on and we select this node and we copy here. Yes, we select again this node and we copy here. So now we have the same structure twice, and for K0 we released the horizontal support, so therefore we must have a roller here without with this distributed load. We go to the support and we have this roller which has the following configuration. And now we just assign this node, so now we have a roller, and yet we do the same thing for case 1, which we had a roller. And now this case 0 is completed, where the only thing to be done is to remove this dead load for case 1. So let's just delete this one. And now we need to add the point load acting horizontally at node number 9. So we assign a load definition, and now we are at nodal forces. So we just add this one, and now we assigned it as -1. So we just click add. Now we're going to have the force here, and we can run the calculations and everything will be okay. It will ask for a separate structure, so just continue yes. And now we are going to have these values for the frame. If one wants to normalize the diagram, they can just go to the result for members and just can hit normalize here. And by using the buttons page up and page down, they can increase or decrease the text descriptions on the frame. So this concludes today's video. I really hope today's video. If there is any questions, please leave them down in the comment section below. Please do not forget to like, share and subscribe. Thank you very much. See you on the next video.